Okay, and let's we start again to analyze the stress analysis, and we call it FEA analysis. Yeah. In Inventor, actually, we have several analysis we can use. For example, here environment. Yeah, like frame analysis. Maybe next meeting I will introduce you about this. And dynamic simulation. Actually, I want to use this dynamic simulation, but our computer specs is not good enough for the dynamic simulation. I did it, but when I did, the program is error, so I cannot open this one. Okay, but no problem. The animation today I will show you how to analyze the what is that fine element analysis. We call it as FEA, right? All right, let's start. Okay, before that, we already designed this one, right? Okay, so we just open this file. I will finish and I will try to open new file. All right, let's go to open new file and go to assembly and standard millimeter, and then place the object. Yeah. Okay, this one. Click this one and right click. Click rotate X 90 degrees and click first one time. Right. Sorry, I repeat it. I repeat. Press again. Gearbox. Okay, this one. Jadi this one not lab 12 ya, but this one lab 13 actually. Sorry. Okay, and then right click. Okay, and then click and say okay. Click okay. Okay, if you want to erase this one, just hide this one. Okay, visibility off. All right. How to do this? The analysis, we need to give the material first for this object. And you can go to the environment and stress analysis. Okay. And create study. Here's the setting. You don't need to change here. This is default setting, and then we just change the name. Is, for example, here's F force analysis. Okay, right, and then click OK. All right. After that, you can give the material for this object. Actually, I already give the material, but I can give it again. Click this one and go to material. Okay. Try to find what is the suitable object material. For example, here, yeah, iron cast. Click and bring it to our library, and then you need to click it first. Yeah, click it first, and then you need to assign to the selections. Now we already give the material for this gearbox. Okay, the next step is we need to fix the constraint. We give the constraint. Okay, click fix constraint. Okay, and then we need to give the constraint here. Okay, it will be here. Fix mean they will not move here. They will move when the force comes. This one also. Okay, this one and this one. Okay, this one. You need to give the constraint from here. Okay, and this one also. We will simulate both here, both sides. This one. Okay, What else? This one, yeah. This one. This one. Okay, and also this one. Let's retry, and we need to give by. All right, and we continue to give the. Sorry, I want to check. Is it equal it? Okay. I want to give the force, yeah. Click force. Where is we want to put the force? Because our okay, the sharp will be here, right? So the force will be here and here. Okay. Also this side. Okay. Right. And then this is only example, yeah. You can try and explore by yourself how to make this analysis actually. Okay. I will repeat because of the error for line error, eh? Not stable. All right. Now I will repeat, yeah. I cancel. I do cancel. I repeat. Click the force and put the location here, here, and here, and here. Okay, the force is like this, right? So we assume the force is like this, perpendicular. So we just change the direction, change the direction. Okay, you click the direction first, and you click this arrow. Okay, you select the vertical axis wherever you want. It's okay, no problem. For example, you select this. All right, and then we can give the force. For example, here 8,000 Newton. 8,000 Newton means 800 kilogram, right? Right, because this one change become force magnitude. You can remember F is equal M multiplied by A. Yeah, and then 5. Yeah, let's we try to simulate it and run. Okay, what happened? Okay, and then try to animate it. Okay, this is the result. And then we can change the mesh. Yeah? Click mesh. Okay, this one we can see the texture of mesh. We can make it become more crowded. I mean, close to each other. Okay, how to change the mesh? Just click here. Oh, sorry, click here. Yeah, local mesh. You can click local mesh here. Here, yeah, and also here. Sorry, here. Also can be here. Yeah, and also here. And you can give the higher mesh the white the texture, but the closer mesh it become like the I mean this the lower the small number of this one. For example, you give for example here 1, and you can see, and after you click OK, you update the mesh. Update, and it can be calculated for you. You can see. Okay, sorry. I repeat. repeat again for mesh, yeah. And we can actually give the different mesh. For example, here you want to give here mesh, local mesh, yeah. Here already, yeah. And this one already, and but here, yeah. Okay, change the mesh and change it become, for example, one. Okay, okay. If you give higher number, so the mesh become high, I mean bigger, yeah. And then click update mesh, update, right? And this one become like this, yeah. Okay. See, this one is different, right? This one also different. So you can try to simulate again. Run. You can see the mesh is seem like that, yeah. Try to sorry animate it. So what is the meaning of mesh? So the higher mesh, I mean the closer mesh, will make the object become stronger. Yeah, it's not easy to give the force. For example, with the higher number of mesh and higher number of force, so it become very weak. So when you give the force higher and then you also increase the mesh, I mean, become closer, so the the object become stronger. Yeah. Okay. And I think that's all. You can sorry. I will give you how to check the report. Yeah? Report can be checked here. Okay, this one report, and you can change the name, everything. Yeah, and you can change the position where do you want to save the file, and also click OK. All right. So it can calculate for you all the things that including in the analysis of stress. Okay, this is the result. You can see the result. Okay, you can from here you can change the image quality. Yeah? When you download it, okay, become higher, become bigger. Yeah? If you make it slow, low pixel, it becomes small. Okay, I suggest you use 800. It's okay. And also you can see here the force analysis, the element size, and also we can change. We can see the what is that we call is sorry. Okay. Mm, the differences. I mean, the displacement is important. Yeah? I mean, when they give you force, so how the length changing because of force. Yeah? This is displacement. Yeah? For example, from A to A1 and A2, so A displacement is A2 minus A1, like something like that. Okay, right, and also can see the so many, yeah, you can see. Okay, E displacement, Y displacement, Z displacement, and so forth. Yeah. Okay, you can try to elaborate the meaning of this. I also still learning about this. Yeah, it's also good for you when you design the something like machine or engine or something like that. Okay, today thank you very much and hope you are happy with this lab and sorry for a lot of things we should do. The next lab, so the next lab you should you need to save this file. I mean the file this for this gearbox, and we will continue for giving pulley animation. Yeah? And also we do something like a frame analysis, visualization, okay, and animation. Thank you very much and bye. Assalamualaikum warahmatullahi wabarakatuh.